Hello, my name is Ben Canning, and we are going to walk through how to do min and max slope with our min-max slope practice using some gas law data. You'll notice first thing, you should be able to find this on Canvas or wherever we're posting assignments nowadays. You'll notice first thing that there are two tabs down here. There's one tab for you to do on your own, that's the solo work with third law, and then the one we're going to do together is Charles' law. We can look up at the top and it says for Charles' law, the setup was we kept the pressure at 35 atmospheres, the number of particles or moles at 300 small particles, and that the uncertainties on this are made up for the purposes of learning. The data is also a little bit rounded just to kind of make it more realistic in a less controlled environment than what a simulation would do. For reference, we have a link to the simulation. You do not need to do anything with the simulation. It is just there for reference to give you a sense of what this setup was. So I'll show you that real fast just so you know and have a sense of what's going on. But for here, what we did was we had Charles' law. We were setting it to 300 particles, so I bumped this up to 300. We are holding the pressure constant. So we're going to hold pressure, and in this one we are looking at how temperature changes will affect the volume, aka the width. So we're going to look at pressure staying constant, and then the volume is going to float based on our temperature changes. And so what I did to collect this data is I just heated and cooled this, and then I recorded the width of it, which is effectively the volume since it's a fixed height. I recorded the width of it, which is, again, proportional to the volume. And so we were able to look at that relationship. And again, the pressure stayed at 35 atmospheres. Again, you do not need to do anything with that simulation. It's just so you understand where the data is coming from. So we collected this data of temperature and width. And what we're going to try and do is fit a min and max slope to it. And then down below, we're going to record our equation for the trend line. We're going to record the maximum slope, the minimum slope, and therefore also the uncertainty in slope. To start off, first thing you're going to do is highlight all four columns because we're going to use these two columns to create our min and max slopes later on. First, we need to see the real data or the original data. So I'm going to go to graph. I'm going to switch it to a scatter plot, and then I'm going to go over here to customize. Let's go ahead and add in our chart title and axis title. So here it is width versus temperature for was it the PhET gas law simulation with 300 particles. Then we'll go ahead and put horizontal axis title. Our horizontal axis was our temperature measured in Kelvin. And then our vertical axis title is going to be width measured in nanometers. I realized I reversed my chart title, so I should probably do my Y versus my X. Let's see what I said. Y versus X. Yes, I did it correctly. Cool. So we've got a title up there. I could be a little more detailed, but you get the idea of it. Cool. Next, I'm going to move this over to here. I'm going to make it a little bit smaller just so I can fit it in on my screen while we're working. And what we're going to be doing is using these two columns right here to plot to plot 2 points for each column for the min slope and the max slope, and we'll use those points to create a line of best fit. But before I do any of that, let's go ahead and put in the error bars on the original data. So for this one, I'm going to go back to edit chart. I'm going to go to customize. I'm going to go to series. It tells me that my error bar size was 2, so we're going to go ahead down here and say error bars, change it from percentage, which we can see is getting bigger and bigger and bigger and bigger, to constant, so that it is a constant value of 2 nanometers. I'm going to go ahead and fit a trend line in there, and I'm going to label use equation. Cool. So we've got an equation, trend line, etc. for those things. All right, next thing, let's go ahead and fit in our data points that we're going to use to kind of manually fit a minimum trend line. Now, there are some applications that you can actually just draw in a trend line and it will tell you what the equation is. Those applications are awesome. We don't have one. Or actually, we just don't have one that works on Chromebooks is what it is. I think if you want, you can use Logger Pro 3. You can request it from me or your IB physics teacher. And you could use that app to do it, but it only works on full-fledged laptops, not on Chromebooks. So what we're doing is kind of a makeshift way workaround using Google and what we have available for free. So first of all, the idea of a minimum slope is this idea of taking a trend line that is the smallest or flattest slope that can still fit through all of my data points or their error bars. So what we're going to try and do is have a line that starts somewhere up in this area right here and ends somewhere down in this area. It's not exactly lined up with the first and last data point error bars because sometimes those aren't where you need to line it up, but it's going to be close to it. So to start off, I'm going to say, okay, we want this data point to start at 5 plus 2, so probably at about a 7. And then it needs to end at whatever the 15 one was, or the 14, so it looks like 14 minus 2, so probably at about 12. So over here in the minimum, I'm going to start off by saying 7, and I'm going to say the other end is 12. And we can see that those data points are plotted right here for me immediately. So as soon as I click out of this, we plot it. Those look about the right spot for my points, so I'm going to leave those there. And then I'm going to do the same thing for the maximum slope, where I want it to go from the bottom area down here to the top area up here. So that means I'm starting at about 3, that's the 5 minus 2, and ending at about 16, that's the 14 plus 2. Cool, those are kind of our good guideline points for now. Now what I need to do is fit trend lines to those and make those points disappear. So I'm going to go to chart, I'm going to go to customize, I'm going to go to series, I'm going to go ahead and turn on trend lines for, I'm just going to do them independently. So instead of applying to all series, I'm going to go to minimum and I'm going to say I do not want error bars, but I do want a trend line and I do want to know the equation of the trend line. I'm also going to go to the data point size and I'm going to change it to none. And we'll see those points disappear so that all I have is a line instead. I'm going to scroll back up and I'm going to go to the max and I'm going to do the same thing where I'm going to change the data point size to none and I'm going to fit in a trend line and I'm going to say use equation. Cool. Now it's a lot of data to fit in on my tiny little graph, so let me close that and go ahead and make it bigger. So now we see what we have are a minimum slope and a maximum slope that go through most of our data points and their error bars while not having any actual point on the graph. But it gives us our minimum slope right here, our maximum slope right here, and we can use those two to figure out the uncertainty in the slope. Before we do that though, I'm going to see if I can tweak my minimum slope a little bit. I think I can actually get away with, looks like it's just barely hitting that. So I probably need to adjust this to maybe like a 12.1 or something. Yeah, that's a little bit better. And this one looks like it's just missing the top of it. So maybe we'll do that one at 6.9. Yeah, that looks just a little bit better, like what's hitting all of them. For my maximum slope, it looks like it's actually going through all of them. Yep, I don't think I can really get that any closer to the edge there, and it's still hitting all of these. Over here it looks like it's just a hair above, so I'm going to go ahead and bump that down to 15.9, and that's a little bit better. Cool. And so now we have our minimum slope, our maximum slope on our graph. You can play around with like the formatting when you do this. Sometimes it helps to take the graph space right here and drop it down a little bit if you want the equations up there. But you can also just make your graph bigger and kind of play around with where the legend should go to make it all make sense. So for my equation for my results, I'm going to go ahead and say that is based on my original graph. So we would say t sorry, not T, W for width equals 0.334 times T for the temperature minus 0.0268 is my equation. The maximum slope was 0.0469. The minimum slope was 0.0189. So to figure out my uncertainty and slope, I just say max minus min, and then I divide those by 2. I need to put that in parentheses so it divides both of them by 2. And then, so my uncertainty and slope is 0.014. So that means that really what's going on here is I know this number down to about 0.014. If I actually round this to 1 sig fig, it means I should probably actually change this to, let me write it over here instead. I should actually change this to W equals 0.33, 0.33 T minus 0.03 if I'm rounding appropriately, as opposed to carrying extra sig figs out beyond what I actually know. And here my uncertainty and slope is 0.01. So that tells me we know this number, the 0.33, give or take 0.01 is kind of where it falls in between. So that's how we go about this, or that's how we go through this. What you're going to do now is do that same process over here on the third law. And again, you're just going through that same process, fitting a max and min slope. Again, the whole purpose of this is so that we can tell how well we know our equation for our results. That's it for me. Good luck on that. And if you have any questions, don't forget to ask your teacher.